This video is regarding automata theory. So what is automata theory, and basically why we study this subject, and we look at what are the fundamental concepts and how it has come into existence, and why computer science students or any aligned branch students should study this subject. Okay, so you have a subject called formal languages and automata theory in second years, or some colleges and some students have a combination of automata theory and compiler design. So all students who are interested in learning automata theory can go to this, can watch this video. Okay, fine. So basically, what is this automata theory and why we have to study a subject called automata theory? Automata means automatically. So without involvement of human brain, how machines can do computation. Okay, suppose if I give two integers 2 and 3, and when I ask to calculate sum of two integers 2 and 3, so 2 plus 3 it is 5. So now the task here is, so before computers have come into picture, scientists want some machine where they can do work on their own. So without involvement of human brain, how computations can take place, that is the job of a automata machine. Okay, so initially they have designed some automata machine with there are some drawbacks or pitfalls, and then again they have revised it and a so-called name. Now this automata theory is study of abstract machine. Okay, so I'll just show you. Yeah, so this is here at automata theory is study of abstract computing device. Abstract means which do not exist in real world, but their idea has been used in designing any compiler or a text editor, or which has been used in designing a new thing. Okay, so basically why it is linked with compiler design is automata theory concepts which have been used in designing. These theoretical concepts have been used in designing a compiler. So that is the reason you are studying automata theory and compiler design together. Okay, now so study of abstract computing devices or machine. So automaton is nothing but we say an abstract computing device. Okay, so now what exactly we have in automata theory is, we have there are 4 abstract machines in automata theory. First, they have designed a machine called finite automata. Now there are some drawbacks with it which it cannot handle. Then they devised another machine called push down automaton, and then later on linear bounded automata, and then finally they devised a machine called Turing machine, which is equivalent to present day's computer. Okay, so now here a fundamental question in computer science: find out what different models of machines can do and cannot do. So what this machine, initially they devised a machine called finite automata. What it works and what it will do, that we'll see here. Okay, now finally Alan Turing, which is equivalent to present day's computer. We say he is father of modern computer science, English mathematician, studied abstract machine called Turing machine even before the computers existed. Okay, so this is regarding all. Okay, now so there are some central concepts which are required to understand the subject. First thing is an alphabet. Central alphabet is nothing but set of symbols. We say 0, 1. Okay, words or sentences means combination of these symbols, we call it as words. Okay, 0, 1, 0, 0. So there are two in 0, 0. There are two symbols called 0 and 0. Language is a set of sentences. Okay, so grammar is finite list of rules defining a language. Okay, language is a collection of sentences of finite length, all constructed from a finite alphabet of symbols. Okay, so this is your central concepts. Okay, now this is the thing. So there is a subset, and okay, initially they devised a machine called finite automata, later on push down automata, and then context sensitive linear bounded automata, and finally Turing machine, which is equivalent. Now this is subset concept here. Finite automata, which is DFA, is a subset of PDA. Means a PDA will have all the capabilities of finite automata, and as well it has got some extra capabilities which finite automata does not do. Okay. Now PDA is a subset of LBA. So LBA has the capabilities what a PDA does. Apart from this, it has got some extra capabilities. Okay. Now Turing machine is superset of all. So Turing machine will have capabilities of LBA, PDA, and finite automata. Apart from this, there are some extra capabilities which all these machines cannot have or which will not do. Okay, so this connectivity is given by a scientist called Chomsky hierarchy. Okay, so these are all central concepts and yeah. So an alphabet is a finite non-empty set of symbols. We use the symbol sigma to denote an alphabet. Example: sigma equals 0, 1, all lowercase letters, alphanumeric sigma equal to A to Z, DNA molecule letters A, C, G, T, like this. So string or word is a finite sequence of symbols chosen from sigma. Empty string is epsilon. So length of a string W denoted by mod W is equal to, okay, so length of a string is nothing but how many number of characters or symbols are there in a particular string. Okay, I'll tell you example: x equal to 0 1 0 1 0. So there are 6 1 to length of the string x equal to 1 2 3 4 5 6. Okay, so epsilon we don't count it here. 0 1 epsilon means the length of the string is epsilon, we won't count it. 0 1 3 4 5 6. G is also 6. Okay, so xy is concatenation of two strings x and y. Okay, so power alphabet, which is important, let sigma be an alphabet. Sigma par k is set of all strings of length k. So sigma star is sigma par sigma power 0 union sigma power 1, all possible string lengths. Sigma power 0 means which string length which is of 0, which is epsilon. Sigma power 1 is string length 1, sigma power 2 is string length 2, so on like this. Sigma power plus means it minimum string length should be 1. Sigma power 1 union sigma power 2 sigma 3, so on. Okay, so L is said to be a language or alphabet sigma only if L is subset or equal to sigma star. Okay, so phi denotes the empty language. So yeah, so finite automata, there are some applications like using finite automata. First abstract machine, which is finite automata. So basically these have been used for designing and checking the behavior of digital. Some applications like we can take it first module of a compiler lexical analyzer has been devised using concept of finite automata, and the software for scanning large bodies of text web pages for pattern. So this is the application. So now next what we